Hey guys, it is Miss LaGrone back again, and this week we are talking about one of my favorite subjects in chemistry. It's called the mole. So there's a couple things you're going to need for this whole session, and the most important thing is a calculator. You need a scientific calculator. So grab one of those because I need you working these problems with me, because the more mole problems you work, the better you're going to get at it. So some of you may have heard the term mole before throughout chemistry. Some of you may not. So we're going to talk a little bit about what that is today. But what I need you to do first is rewind your brain all the way back to like the first and second week of chemistry class, where you guys studied something called dimensional analysis. What is dimensional analysis? All dimensional analysis is converting from one unit to another unit. If you can do dimensional analysis, you can do mole conversions, you can do what we're going to do in the next few weeks called stoichiometry, you can do all those things. But I want to shake off some of those conversion cobwebs first and really get down the structure of how you need to work all of these problems for just about the rest of the school year. So let's look at this problem up here. How many seconds are in 5 hours? So what we're going to do first with any problem that we do from now to the end of the school year, just like you were taught in math, you always start with your given. And in this case, our given is 5.0 hours. So we're going to start with our given, and we're going to write that down. Well, if I can get my pen to write. So we're going to start with our given, which is 5.0 hours. In the next step, you're going to do something easy. You're going to draw an X, and you're going to put a line. You're going to follow these steps every time, no matter what problem you're given. The next step is you take the unit that you're given, and you're going to put it on the bottom, because if you have a unit on the top and a unit on the bottom, they're going to cross out, just like variables would. So we're going to put the unit hours on the bottom. Well, what are you trying to get to? I started with hours, and I'm trying to get to seconds. Okay, so you may or may not know a conversion right in your head to go from hours to seconds. Let's say you don't. Let's say you can't think of how many seconds are in an hour, but you can go from hours to minutes. So on the top, I'm actually going to convert from hours to minutes. This right here is called a conversion factor. And a conversion factor has to be an equivalent set of numbers. So, for example, this conversion factor, we need some things that are equal. In this case, we know that 1 hour equals 60 minutes. So those are going to be the numbers that we're going to put in there to make that conversion factor true. The next step, and again, you're going to follow these steps all the way through, are you're going to cross out your units and see what's left. So we're going to cross out hours, and you're left with minutes. And you ask yourself, is that what the problem wanted? No. The problem wanted seconds. So that means we have to keep going. So what do you do when you got to keep going? You're going to draw just another X and another line, and you're going to follow the same procedure. We're going to take the unit that's at the top, which is minutes, and we're going to put it on the bottom to cancel out because we don't want minutes. And in order for something to cancel out, you have to put it on the top and the bottom. Well, my end game is to get to seconds. So what do I need to do? I need to find some sort of conversion between minutes and seconds. And hopefully you know that one. You know that 1 minute is 60 seconds. So what we do now is cross out units. We cross out minutes on the top and minutes on the bottom. And you see if you're left with what you wanted. I wanted seconds. And if I look here, I see that's what I'm left with. So now that you have your units correct, all you do is multiply anything that's across the top and divide anything that's across the bottom. So go grab your calculator, and in this particular instance, I'm going to put 5 times 60, because it's on the top, times 60, because it's on the top. And that's going to give me 18,000. Now in chemistry and in science, we don't leave just numbers. You have to have a unit with your number. And the unit that was left, everything crossed out except seconds. So my answer would be 18,000 seconds. Now, the last thing in chemistry you have to check, and you probably did this week 1 or 2, are the number of significant digits that are in this answer. Look at your given. This given has 2 significant digits, the 5 and the 0. Your answer has to have the same number of significant digits as your given. So if this has 2, then your answer needs to have 2. And if you remember back from sig figs, 18,000 actually has 2 significant digits because these other zeros are acting as placeholders. So your answer is 18,000 seconds. Now here's the deal. If you can do what we just did, you're going to be able to work every problem today. We won't get any harder than 2 sets of conversions out. So let's talk about how this relates to the mole. What is stoichiometry? Stoichiometry is nothing but converting from one unit in chemistry to another unit in chemistry. You do exactly what we just did here. You have to remember, you always start with the given and you cross units out to get to the unit that you want for your answer. So start with your given, use those conversion factors, which are equivalent factors written in a fraction form, to cross out units to get to the unit that you finally want. Then multiply across the top, divide by the bottom, and then check your work. So now let's talk about how this relates to chemistry. When you go buy eggs, or when the hot light is on at Krispy Kreme, how do you buy donuts and how do you buy eggs? You don't usually buy one egg, or you probably don't just go to Krispy Kreme and buy one donut. You probably buy a dozen. Okay? When you're buying shoes, you probably don't buy one shoe. You buy a pair of shoes. So a dozen and a pair are just like a mole. A mole is just a way for chemists to write a number of something. So if I had a dozen basketballs, I know that I have 12 basketballs. If you have a mole of something, that's actually telling you that you have 6.02 times 10 to the 23rd units of something. That's a really, really large number. That's actually, if I wrote it out, the number 602 with 21 zeros after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if you have a mole of something, you have that many of something. So if I had a mole of sodium atoms, you would have that many sodium atoms. The reason chemists use a mole is probably obvious now. That's a really big number to write. So we need a way to condense that and talk about it in numbers that are more scalable. When we talk about a mole, we're going to be talking about any kind of representative particle. So you're going to hear us say atoms or molecules or formula units. And this is going to give us our first conversion factor. Throughout the rest of the series, so throughout the end of May, I'm going to ask you to memorize 3 conversion factors, and we're going to learn 2 of those today. So write these down somewhere very important. The first conversion factor we're going to have that you'll need to remember is 1 mole of anything is 6.02 times 10 to the 23rd particles. Okay? Write that down. The 1 is always going to go with the word mole, and the number 6.02 times 10 to the 23 is always going to go with the word particle. You can absolutely use a couple other words instead of particles. So for example, if you have an element, you're not going to use the word particle, you're actually going to use the word atoms to describe an element. If you have a covalent compound, you're going to use the word molecules. If you have an ionic compound, you're going to use the word formula units. If you have ions, you're going to use the word ions. So that number 6.02 times 10 to the 23rd can go with any of those words, but the word mole is going to have the number 1 with it. So let's do some of these calculations. We're going to calculate the number of atoms in 3.50 moles of copper. So what did we say we had to do first? The first step is you start with your given. what is our given here? Our given is 3.50 moles of copper. So I'm going to write that down. 3.50, the abbreviation for mole is MOL, and you have to put the chemical. I'm going to put moles of Cu, because in the next couple weeks, I want you to get into practice with this. In the next few weeks, we're going to be converting not just from atoms to moles and moles to grams, but from one chemical to another. So make sure you keep your unit together with your chemical. So the first step is write the given. What was the next step? Even with the second question. The next step is you draw an X and a line. The next step was you take the unit that you're given, which is moles of copper, and you're going to put that on the bottom to cancel out. So we're going to put moles of copper on the bottom. Now, what are we trying to get to? We're trying to get to atoms of copper. And do I have a way to get from moles to atoms? The answer is yes. It's right here. I can go from moles to atoms. So on the top, I'm going to put atoms of copper. What number goes with atoms? So find the word atoms, and the number that I always put that is called Avogadro's number. That is 6.02 times 10 to the 23rd. Now look at your conversion factor, and what number did I say always goes with moles in this particular conversion? In this conversion factor, we put a 1 with mole. So now that you have your numbers, the next step is you cross out your units. I have moles of copper on the top, moles of copper on the bottom, and that leaves me with atoms of copper. And is that the unit that you wanted? Yes, we wanted the number of atoms. So from there, now that your units are right, you can write an equal sign, go grab your handy dandy calculator, and we're going to enter this into our calculator. Now, whenever you enter a number that's in scientific notation into your calculator, you have to have a scientific calculator, look for the button EE or EXP, and I'm going to walk you through how to input this into your calculator. So in this problem, I'm going to put 3.5 times, because remember when it's on the top, we multiply, and I'm going to type in 6.02. I'm going to type the button that says EE or EXP. That button means times 10 to the, and I'm going to put 23. So do not type in 3.5 times 6.02 times 10 to the 23rd power. When you start doing that, once we get a lot of these conversions in a string, it can get messed up. Whenever you see a number like this, you type in 6.02 EE or EXP 23. Then I'm going to hit equals. I have 3 sig figs in my given, so I need 3 sig figs in my answer, which tells me it's going to be 2.11 times 10 to the 24th atoms of copper. Make your chemistry teachers love you, circle or highlight the answer for them, because there's a lot of work up there. So let's try another one. Calculate the number of molecules in 2.6 moles of water. We see our given is 2.6 moles, and we want to get to molecules. Same process, start with the given. So I'm going to start with 2.6, oh, not 2.60, that's the wrong number of significant digits. I'm going to start with the number 2.6 moles of water. What was the next step? The next step, we're going to get faster and faster, is draw an X and a line. What was the next step? Take the unit that you want to cancel and put it on the bottom. So on the bottom, I'm going to put moles of H2O. Now I have to figure out what I'm going to put on the top. I want to get to molecules. Can you put moles and molecules together? Yes. It's right over here in this conversion. I can put moles with 1, and I can put molecules on the other side with 6.02 times 10 to the 23rd. So on the top, I'm going to put molecules of H2O. Look back at your conversion factor. What number goes with molecules? With molecules, you have 6.02 times 10 to the 23rd. And look back at your conversion factor. With moles, you have 1. Cross out units on top and bottom. You're left with molecules of water, and that's exactly what you wanted. So we're going to stop and put this in our calculator. So let's put this in. 2.6 times, because it's on the top, and anything across the top you're going to multiply, 6.02 EE23. Make sure you check sig figs. I need 2 in this case, and that's going to give me 1.6 times 10 to the 24th molecules of water. All right, so easy. Treat it just like you would a dozen or a pair or seconds to minutes, and you'll always be able to get these questions right. Just remember, one will go with mole, and then Avogadro's number will go with anything other than that. Molecules, particles, atoms. Let's try another one. How many moles of MgO are in 9.72 times 10 to the 23 formula units of MgO? Same thing, start with your given. In this case, we have 9.72 formula units of MgO. And what's next? Next is we draw an X and a line. Keep following the same process. What happens next? We take the unit that's on the top and you drop it to the bottom to cancel. So we're going to put formula units of MgO at the bottom. Now let's go see what we want to get to. We want to get to how many moles. Can you put moles and formula units together? Yes. Look right up there at that conversion factor that we have. So on the top, we're going to put moles of MgO. Now look at this. Don't memorize the one goes on the top or the one goes on the bottom. You memorize that the one goes with the word mole. So we're going to put 1 with mole, and what number goes with formula units? Look back at your conversion. It's 6.02 times 10 to the 23. So we're going to cross out formula units, and you're left with moles of MgO, which is exactly what you wanted. So we can stop. Now we're going to put this in our calculator. Pull out your calculator, make sure you're typing it in exactly as I say it. This was actually, 9.72 times 10 to the 23rd. So in our calculator, we're going to put 9.72 EE23. Now this is on the bottom. It's not on the top anymore, so we don't multiply. What do we do if it's on the bottom? If it's on the bottom, you divide. So I'm going to say 9.72 EE23 divided by 6.02 EE23. And that gives me to 3 sig figs, 1.61 moles of MgO. Everybody feel good about going from moles to molecules and moles to formula units? Now we're going to learn one more conversion factor today, and it's called molecular weight. Okay, we're going to go from moles to molecular weight. The molecular weight of a substance is how much 1 mole of that substance weighs. So if you go to the periodic table, the molecular weight of that element is actually that number on the bottom. It's that decimal place mass that you're looking for. And we usually, as a good practice, go out to 2 decimal places. So let's look at this. Let's find the molecular weight of some of these things. So go grab your periodic table, and let's look at calcium. So go find calcium on your periodic table. He's right here, number 20. And the molecular weight of calcium is 40.08. We're going to round to 2 decimal places here. And the unit is grams per mole. So let's look up sodium. Let's go over to sodium on the periodic table. That's number 11. And I see that it's 22.989. If I want 2 decimal places, that's going to give us 22.99 grams per mole. All right, what do you do if you have a compound? Compound is just when you take elements and you chemically put them together. So let's look at NaCl. NaCl is just going to be the weight of Na plus the weight of Cl. So we're going to go back to our periodic table. We see that sodium is 22.99. We find Cl, which is number 17, and that is actually 35.45, which gives me a formula mass of 58.6 0.44 grams per mole. H2O. What if you have two elements in that compound? Well, that means you have two H's, so you need to multiply that weight by 2. So in this formula, I need to take the weight of hydrogen and multiply it by 2, and then add the weight of oxygen. So if you go back and look at the periodic table, the weight of hydrogen is 1.01. I say 1.01 times 2, which gives me 2.02. And then I'm going to add the weight of the oxygen, which is 15.999, which we're just going to round to 16. And that's going to give me 18.02 grams per mole. Same thing with Fe2O3. You would just take the weight of iron, multiply it by 2, take the weight of oxygen, multiply it by 3, and then add those things together. That's going to give us a new conversion factor. That new conversion factor that we're going to use today is 1 mole over the molecular weight. This number comes from the periodic table. And 1 is the number that's going to go with moles. So let's work a couple of these problems. Calculate the mass of 1.630 moles of Na. So we start with our given, the exact same way that we've done before. 1.630 moles of Na is our given. What do we do after that? You draw an X and a line. After that, same procedure. Take the unit that you're given, put it on the bottom to cancel out. We want moles of Na to go on the bottom to cancel out. What are we trying to get to? This time we're trying to get to mass, and mass is in grams. Okay? So let's look. Do we have a conversion over here to go from moles to grams? And we do. It's this conversion right here. I can go from moles of a substance to grams of a substance using that number that's on the periodic table. So over here, I'm going to put grams of Na because I can put moles and grams together. 1 goes with moles, and where do we say we get grams from? We get grams from the periodic table, and that is actually 22.99. You cross out moles and moles. You're left with the unit that you wanted, which was grams, so we put it in our calculator. So you're going to type in 1.630 times 22.99, and that's going to give you 37.47 grams of Na. So same exact process. You're just using those two conversion factors. So let's try one of these. Let's talk about how many atoms are in 25 grams of gold. Same process, and this is the hardest one we're going to do today. So we're going to start with 25.0 grams of gold. Gold is Au. Put an X and a line. On the bottom, put the unit you want to get rid of. In this case, it's grams of Au. What are you trying to get to? You're trying to get to atoms. Is there one of the conversions that I gave you to go from grams to atoms? No. You cannot go from grams to atoms. You can go from grams to moles, and then you can go from moles to atoms, but you can't do that in one step. So we're going to have to do a two-step problem. So on the bottom, I'm going to put grams of gold. On the top, I'm going to put moles of gold. Look at your conversion factors. When I have moles and grams together, moles is 1. Grams comes off the periodic table, and Au is 196.97. You cross out grams of gold and grams of gold, you're left with moles of gold. That's not what you wanted. You wanted atoms. So you have to keep going, just like that second problem we did at the beginning. On the bottom, you do the same process. We're going to put moles of gold to get these to cross out, and we're trying to get to atoms of gold. And you can put atoms and moles together, just like we did at the beginning. We're going to cross out moles and moles. 1 goes with mole. 6.02 times 10 to the 23rd goes with atoms. You're left with atoms of gold. So we're going to put that in our calculator. 25 divided by, because it's at the bottom, 196.97 times, because it's on the top, 6.02 exp23. And that gives us, if you got 25 grams of gold, you're going to have 7.64 times 10 to the 22nd atoms of gold. That's the hardest problem that we're going to get to this week. So here's what I need you to know for next week. We're going to do the same types of problems. Please, next week, bring your calculator, bring a periodic table, because next week we're going to be talking about empirical formulas and molecular formulas. And you're going to take the conversions that we did today and work them into calculating some formulas next week. That's all I have for you. I know it was fast. Rewind it back if you need to. Watch it a couple times and we rework these problems. And we will see you next Wednesday at 1:30. Thanks, guys.